everyone, we're going to find the derivative of the function using the definition of the derivative. We're also going to state the domain of the function and the domain of its derivative. Now let's go ahead and do the domain of our function f. This is really the square root of x cubed. For the square root, the inside function x has to be greater than or equal to 0. So you could write the domain of f as just 0 to infinity. Now let's do the derivative and see what we can do with that. This is our definition of the derivative. I know it's kind of small here. These are all on my Facebook page if you ever want to save a photo. But what we're going to do is take the limit, or let's do f prime of x. And that's going to be equal to the limit as h approaches 0. And we're going to do x plus h for our x. So this is going to be x plus h to the power of 3/2, and then minus x to the power of 3/2. That's just minus your function. Divide it by h. All right. Now what I'm going to do is multiply this by the conjugate. Now basically what that means is, because this is square root, right? These are basically square root of x plus h cubed. So all I have to do is multiply this by x. Let me do this. Yeah, I'm right. X plus h to the power of 3/2, and then put plus instead of the minus, x to the power of 3/2. But you also have to divide this by whatever you're multiplying the numerator by. So this is going to be x, and we have this h. So this is going to be x plus h to the power of 3/2 plus x to the power of 3/2. Now what you get is equal the limit as h approaches 0, and we're looking at our, we're doing a minus b times a plus b equals a squared minus b squared. So this is your a and this is your b, a, b. So what we're going to do is write this as x plus h to the power of 3/2 squared minus x to the power of 3/2 squared. And then in the denominator, we're going to have h times x plus h to the power of 3/2 plus x to the power of 3/2. And h has to multiply both of those. All right. So when you square this, I forgot to put the square there, we're going to get this equals the limit as h approaches 0 of x plus h cubed, because these will cancel out, minus x cubed divided by h, and I'm going to start calling this until I get this numerator fixed up, d. So this part right in here is going to be d times d. All right, because it'll save some time on the videos. Now let's go ahead and expand this. This is just going to be the limit as h approaches 0 of x cubed plus 3x squared h plus 3xh squared plus h cubed. That's just your expansion for a plus b type cube. All right, so x cubed, and then we still have h times that denominator. And I'm going to put the denominator back in. I just want to clean up the numerator first. So what happens is these two cancel, and I can write this now as the limit as h approaches 0, and I'm going to factor out an h. So this is going to be h times 3x squared plus 3xh plus h squared divided by h times my denominator. I'll go ahead and write it now. So my denominator is x plus h to the power of 3 halves plus x to the power of 3 halves. And what happens is the h's cancel, and now we're left with this in here. Let's go ahead and apply the limit. So when we apply the limit, we're substituting 0 in for the h's. So this will turn to 0. This is going to go to 0. This is going to go to 0. So what we're going to get is 3x squared divided by, we have x to the power of 3 halves plus x to the power of 3 halves, because this was 0. So that's going to be 2 times x to the power of 3 halves. All right. Now the last step is we have this same base of x here. So basically, if you take x to the power of 2 times x to the power of negative 3 halves, I can write this as x to the power of 2 minus 3 halves, which is actually x to the power of 4 halves minus 3 halves. So we have x to the power of 1 half. So my final answer is going to be 3 halves, because we still have the 3 and 2, times x to the power of 1 half. And that is your f prime of x using the definition of the derivative. You could also write this as 3 halves times the square root of x. And again, the domain for this is 0 to infinity, which equals also our f of x derivative, looking at it this way. Strictly speaking, for this f prime of x, the domain is really 0 to infinity. And that's because the limit that defines f prime of 0 does not exist as a two-sided limit. But the right-hand side, using h approaches 0 from the right, does exist. So we can still use this right here for our domain. All right. Thank you. Have a nice day. Bye-bye.